let us write a recursive algorithm for binary search. Right? As binary search is following divide and conquer strategy, let us see a recursive algorithm. So here I write algorithm. R binary search. What are the parameters it takes? Low, high, and key. In divide and conquer strategy, we say that if the problem is large, we split it into subproblems and solve. Then you should also define what is a small problem. When do you say it's small? So if you are able to say this is small, then only you can say the other problems are large. Yes, I say that the size of 15 is large. Then what is small? If there is a single element, then this is small. So how do you solve if it's a single element? If low is equal to high, then it means there is a single element. If low is equal to high, then it's a single element. Then what I do? I check if A of low is equals to key, if it is a key. If it is a key, then return that index L. So if there is a single element that is low and high are equal, then check if that is the key element. This is a single element. See, if it is large, we reduce it to one element, and that one element, if it is a key, then search is successful. Return that index L. If there is a single element and it is not a key, then return index 0, means the key element is not found. That's it. This is a small problem. If there is a single element, check it is a key, take it, otherwise return 0. If the problem is large, what we'll do? Else. As usual, we know we will calculate mid. Mid is equals to low plus high divided by 2. And we check if key is equal to A of mid. That middle element is a key element. If so, we will return mid. We find out mid and check if that key element is present in the mid. If not, if yes, we will return it. If not, then we check whether it is smaller or greater. If key is less than A of mid, then if it is smaller, left hand side, then we perform that binary search recursively on the left hand side. See, for this example, this will be mid, so this is low and this is high, so we perform binary search recursively on left hand side. We'll perform on the left hand side, that is low to mid minus 1. So return R binary search low is as it is, this is mid minus 1 and key. If key is not equal, key is not less, then definitely key is greater. So look for the key element on the right hand side, that is mid plus 1 to high. Else return R binary search mid plus 1. We check from mid plus 1 onwards, that is mid plus 1 to high, and key is as it is. Mid plus 1 to high. Mid plus 1 to high and key is as it is. That's it. Closing of else and closing of algorithm. Now we have written a divide and conquer algorithm, that is recursive algorithm for binary search. Now divide and conquer algorithm, daytime complexities are found using recurrence relation. Let us prepare a recurrence relation for this one. If I say this algorithm takes Tn time, then what it is doing? This is a small problem, right? And this is a large problem. So in this one, it is calculating mid and also checking conditions. So if I take the condition, it will check this one or this one, right? At most it will check 2 conditions. So I will take these 2 also. So 1, 1. Then it is calling by dividing the problem into half, either on left side or on the right hand side, any one. So out of these two, it will call itself for Tn by 2. Tn by 2. And when it is a small problem, if list size is 1, then what it is doing? Just making one comparison. This is small. This is small. So let me write a recurrence relation. Tn is taking one time if number of elements are 1. That's a small problem. If number of elements are greater than 1, then what it is doing? It is calling itself either this one or this one. So only one time it is calling. So this is Tn by 2 plus what? 1, 2, 3. So we write it as constant. So I'll write it as 1. The recurrence relation for binary search using divide and conquer strategy. Algorithm is calling only one time, either this left hand side or right hand side, not both. So I have written it only Tn by 2. Now this recurrence relation, you are familiar with this one. Already I have a video for this one. So this is mentioned there, Tn is equals to, this is mentioned there in the title of a video. You can watch that, how to solve this one. And even by master theorem, there is a video available for master theorem. We have already seen it. So the time for this one by applying master theorem is theta of log n. This is 1 and this is 2. So log 1 base 2 is 0 and this is n power 0. So both are 0, 0. So it is 1 into log n and it is 1 into log n. So it is log n. So the time complexity of this one is log n. So we have seen the divide and conquer algorithm is also giving the time as log n. That's all about binary search.